What's good, everybody, and welcome back to another video. Welcome back to my lab. A bit of a new angle today. I've actually put you guys inside my tissue culture hood. So you guys are currently inside the clean space that I'm about to do some work with cells in, some tissue culture. It's early on a Sunday morning, but today I'm doing some viral transductions, which basically means I'm going to be infecting cells with some virus. And it's quite a long process, so the initial step now will probably take about an hour, and then I have to centrifuge, so spin the cells really fast for an hour, and then I have to leave them in the incubator for 7 hours, and then I will come back to them later on. So yeah, starting early Sunday morning, and I thought I would just bring you guys along for the journey. So yeah, I've kind of cleaned my hood, got a couple of things in here set up, and I'm kind of ready to begin. I'm going to have to get up and move around a lot, but the camera's going to stay fixed. So I hope you don't mind if I walk around, but yeah, the hood sounds are quite noisy if you've watched any of the other tissue culture videos, but if you don't mind the loud hood sounds, hopefully you'll find it relaxing, a bit, just kind of chill hangout session, I guess. So I'm going to go and get my cells, and I'm going to get started. So today, the cells that I'm going to be infecting, some of you who've watched my lab videos before will know that I usually work with airway cells, but today I'm actually doing an experiment with skin cells, and that's because I'm basically trying to replicate some data that has been done before in the skin. Previously in my project, I have tried to replicate these results in the airway, and my results were different. So basically, I'm now going to try and replicate the results in the same type of cells that they used to see if there's an actual tissue-specific difference between the skin and the airway, or if it's just something that I'm doing differently. If that makes sense. I forgot to restock the stripettes. Can't open this one. Okay, so I've got my cells, and I have some trypsin. Not much left, but should be enough. Everything that goes into the hood needs to be sprayed with 70% ethanol to sterilize it. Switch on the aspirator, which is another thing that adds to the noise, unfortunately. So, got my cells in a flask, and I'm first going to aspirate out growth medium. And then replace it with, I will wash with roughly the same volume of medium that was in the flask. So there was 4 mils of medium, so I've added 4 mils of PBS. And then I can aspirate it. Now I can add the trypsin. And so what the trypsin is going to do is it degrades cell surface membrane proteins, which are what attach the cells to the bottom of the flask. And so the trypsin enzyme degrades these proteins, and so the cells come unstuck, and then you can move them around. So I think I've mentioned before, we use a system called co-culture, feeder co-culture. So I have my human skin cells, but they're grown on like a layer of mouse fibroblast cells. And fibroblast cells are like structural cells, support cells in your different tissues. But basically I only want the skin cells. So I'm going to do a first round of trypsin to remove the mouse feeder cells, which come off faster. And then I'll take that away, put a second lot of trypsin on, and then I can collect just the skin cells. So these are going to go into the incubator for a couple of minutes, and then I will check them. And the incubator is set to 37 degrees and 5% CO2, which basically mimics the temperature and CO2 concentration that these cells, would experience in the body. Yeah. So the other thing I need to do is I need to make new growth medium. So I'm going to start gathering the things to do that. So I already have these 2 supplements that I got from the freezer room downstairs. And then I've got some more things warming up in the water bath. So the growth medium, there's quite a few things that go into it. And for this bottle, I'm going to be combining these pots, which is slightly inconvenient, but it's fine. Okay. That is everything. Almost everything. I have some more things that I got out of the freezer earlier. Oops. Okay. One more thing from the freezer. Okay. So I've gathered all the things that I need. However, it's probably time to check the cells to see if the feeders are coming up, so I'm going to do that. I'm going to grab the cells from the incubator and go over to the microscope. And basically, what I'm looking to see is the human cells stuck down and gaps between the colonies where the feeder cells used to be, which is exactly what I see. So these are ready for the second round of trypsin. So what I'm going to do is aspirate this trypsin. And then add another ml of trypsin. This will probably finish it off. It's not quite enough, but luckily I already thawed a fresh aliquot of trypsin. So, no need to panic. If you've never heard the word aliquot before, because I hadn't either before I started in the lab, it's kind of a funny word. An aliquot is basically when you divide a larger volume of something up into lots of smaller volumes. So this trypsin we buy in big 500ml bottles, but basically with most reagents and things in the lab, you don't want to be heating them up and cooling them down too many times because that leads to degradation. So when you want to use trypsin, you need to warm it up in the water bath to 37 degrees before you use it. But if you do that with a 500ml bottle, it might take you a month to get through 500 mils of trypsin. And so if you're heating it up and cooling it down for a month, because you store it in the fridge, you'll basically degrade the enzyme. So you divide it up into 50ml tubes, and then you're only heating up and cooling down a 50ml tube a few times, if that makes sense. So trypsin is on the cells, and I'm going to take them back to incubator, and then I'm going to prepare the medium. So usually the way I would do it is I would take a bottle of D-Men like this, but full, and I would remove some of it and add all of the supplements. But when I remove some, I save what I remove in these pots, so that once I've made 3 bottles of medium, I've saved enough medium in these to make another bottle, so I'm not wasting medium, if that makes sense. So what I now need to do is basically take out medium from these pots and put it into this, and then I'm going to make the medium. So the amount that I need is 500 minus 157.4, so 342.6. So I have 3 lots of 100 here, and then I will measure out 42.6 from this one. I'm just going to pour these in. Okay, so that's the main medium component. Now I need to add all of the supplements. So we have fetal bovine serum, so pour that in, and a bunch of other things. Penicillin and streptomycin, so some antibiotics to help stop the cells getting infected. Have some adenine. And then some other things. Was insulin, something called T3, and a ROC inhibitor. Then I'm going to add some hydrocortisone. EGF, which stands for epidermal growth factor. Give it a shake. And there we go. Growth medium made. So let me put some of these things back now. So the gentamicin and cholera toxin are kept in the fridge. Oops. And so is the F12. The hydrocortisone is kept in the freezer, but it's dissolved in absolute ethanol, so it doesn't actually freeze. Let's just give this a quick clean. There we go. Cool, let's check the cells, see if they are off. Give the flask a little tap. And yes, they are. Good timing. So what I'm going to do now, so the cells are unstuck. Let's turn off the aspirator. So now I'm going to resuspend these in the growth medium that I just made. So I add 2 mL of growth medium, swell it around a bit, and then collect the cells. So I have the cells in here. Transfer it to a falcon tube, and then take another 2 mL and wash the flask. Set the flask aside. And then I'll just label the tube, even though it's the only tube I have, so I know what these cells are, but might as well. Okay, now what I need to do is count how many cells I have. So I'm going to take 10 microliters. Just make sure they're mixed. I'm going to take 10 microliters of cells and pipette them into a hemocytometer, which is basically, there's a small chamber here that I've pipetted my cells into, and then on the plastic there's a grid, and I basically just need to count the cells in the grid, and that can tell me the concentration of cells I have. So I'm going to go over to the microscope and count them quickly. The other thing I need to do is I need to set the centrifuge to warm up to 30 degrees. So I'm going to start that now because it takes about 10 minutes. Okay, so the centrifuge is warming, and now I'm just going to count my cells. So Okay. So I just counted the cells. I counted 358. Which is basically double. So I have 716,000 cells per milliliter, which in total is 3.58 million cells. For each viral transduction, so for each infection, I only need 150,000 cells. So now I'm going to do 150 divided by the concentration, 716, which is 210 microliters. So I need 210 microliters of this viral mix for each infection that I do. And the other thing I'm going to calculate is 750 microliters minus 210 equals 540 microliters. So basically, I just calculated. So when I am doing my transductions, I mentioned that usually we grow the cells on feeder layers. However, when we do the transductions, we can't do the infections with the feeder cells, basically. And so in order to keep the cells happier, we do the infections in something called conditioned medium, which is basically where you collect the medium from cells that are in culture. And that medium will contain loads of growth factors, cytokines, things released by the cells in co-culture into the medium. And these factors basically can, in some ways, mimic the effect of the feeders being there. Not to the full extent, but it's better than nothing. But when you collect conditioned medium, because it's coming from cells that are already growing, some of the reagents and things that I added into the medium, and also stuff that's contained in the growth medium, the like DMEM and F12, which are quite nutrient rich anyway, these things get used up by the cells. And so you always mix conditioned medium 50-50 with fresh medium. So for my viral mixture, I'm going to make a mixture of 750 microliters of conditioned medium containing virus and transduction reagent, and then I'm going to add 750 microliters of cells in fresh medium. So for 150,000 cells, that's 210,000 microliters. So I then need to add 540 microliters of fresh medium to make it up to 750. And then I mix that 750 with the 750 of conditioned medium and virus. And that's it. So what I need to do now is make those viral mixtures. And to do that, I need to thaw the virus. So I went downstairs earlier and collected my virus. They're just contained in these little tubes. And I brought it up on dry ice. to keep them frozen. I have some wet ice here. This is just normal ice. And I'm going to place the virus on top of the ice so that it thaws, but not too quickly. I should have done this earlier because I'm going to have to wait a little bit now. But anyway, I'm also going to get the transduction reagent. Okay, so the centrifuge is warm. Now I just need to find where the transduction reagent actually is. I used it recently. Here we go. So, yeah, the transduction, well, it's not really a transduction reagent because you can just add the virus to the cells and it will infect. It's more of a transduction enhancer. And it's called polybrine. How much am I going to need? I'm going to do 750 times 3. So let's do 3,000. Divided by 65. Okay. 1 second. So I've got 6 times 750. It's going to make 5,000 in total. 8. Is that right? Okay, so I think I only need 8 microliters. So I'm just going to take 1 aliquot. So similarly to the trypsin, we don't want to be freeze thawing the polybrine, so I've got 15 microliter aliquots and then a bag of those in the freezer, so I'm going to thaw this one and then throw the rest away. So I'm going to make 5 mils. Actually, let's go up. So I have some conditioned medium. In the water bath. Let's stop the water bath. The centrifuge beeps really loudly. Okay, so I have conditioned medium. And I have a tube to make my polygreen mix. I'm going to get a second one because I'm going to have 2 viral mixes. So I'm going to take 5 mils of my conditioned medium. And then 8 microliters of polygreen. And then I'm going to give that a mix. And then take out 2.5 mils and put it in the other tube. So similar to this. Okay. So now I have 2 tubes, 1 for each viral mixture. So this is going to be 1 virus, and this is going to be another. Now I need to work out how much virus to add. So I want there to be 2 microliters of virus per well. And so that means 2 microliters in every 750 microliters of conditioned medium with polybrine. So I have 2.5 mils, so I'm going to do 2,500 divided by 750, which equals 3.3. So I need to do 2 times 3.3. So I basically need to add 6.6 microliters of virus into each. Okay, have they thawed? Almost. We'll leave that for a sec and we can begin to prepare the plates. Oh no. Crisis averted. focus. I should have checked that earlier. It's kind of hard to see. Hopefully I've been in focus this whole time. Anyway, I've got a 6-volt plate that I'm going to do the transduction in. So let's label them. So we have the name of the donor, and then I'm going to do empty vector. Date. Yeah. So now what I can do is I can start by adding 540 microliters. Then I can add the cells. So the cells are here, and it was 210 microliters of cells per well. So that's 1, 2, 3, 4, 5, and 6. So now, you see that each well has 750 microliters in a fresh medium containing 150,000 cells. Now I just need to make my virus mixtures and add that. However, when you're working with virus, it's obviously, you're working with virus is not the safest thing if you're not careful. Bless me. So when you work with virus, you need to dispose of everything that comes into contact with the virus extra carefully. So what you do is you take an empty medium bottle and fill it with disinfectant. And then basically everything that touches virus needs to go into here and be disinfected instead of just into normal waste. So I've got my 2 viruses, and it was 6.6 microliters. So basically I have one virus which is going to actually have it should have an experimental effect. And then this virus is called the empty vector. So it's basically exactly the same virus, but missing the one part that should cause an effect in this one. So that then you can confidently say that any effect you see on your cells is because of the extra gene in the virus, rather than just the fact that they were infected by a virus. And then, yeah. So, this is the empty vector one. Let's take 6.6 microliters, add it to this tube, and then this tip goes into the disinfectant. And then 6.6, the actual experimental virus, into this tube. And into the disinfectant. Okay. Now all that's left to do is add the virus to the cells. So I'm going to take 750 microliters. I'm going to put that up and down first to mix it. Okay. That's the first well. Second well. And the third well. So the tip and then the tube into the disinfectant. And then I'll just do the second one. Number 2, and well, number 3. And then I'm also going to put the actual virus tubes in there as well. So I'm going to open them and put them in. I'm going to close this. Okay. So yeah, this is now ready, and I'm going to centrifuge it at 30 degrees, 900 G for 1 hour. First I need to seal the plate though. So I'm going to grab some parafilm. If you've seen some of my other videos in the lab, you'll have probably seen me use parafilm. It's basically a stretchy lab film. I guess it's kind of like cling film, but a lot thicker. I'm basically just going to wrap the plate, hopefully without ripping. There we go. So the plate is sealed, and then all that's left to do is put it in the centrifuge. So to spin a plate, there are these little, I'll come and show you. You have these little like cradles, and that just sits in the centrifuge. And then I need to put a balance plate into the other side. Although I'm not seeing, let's use one of these. Okay. I'm just going to give the cells a bit of a shake back and forth to try and make sure they're evenly distributed. It's actually 920G to be specific. And there we go. I'm just waiting to check that the centrifuge is properly balanced, which you can tell if the see, you can kind of hear that it's making a bit of a wobbly sound. Because for some reason the 6-well plate balance has gone. So I use the 12-well plate, but it doesn't work. So I'm just going to add the same volume of PBS as I do have medium and other things into each of these wells. So this should now be better balanced. Hopefully this will sound better. Not really. But there's nothing else I can do because, to be honest, the centrifuge is a bit knackered. It usually is a bit noisy. But yeah, that's kind of it. That is viral infection done. Well, kind of. Need to wait an hour. And then take the plate out, put it in the incubator, leave it for 7 hours. And then I need to, at the point of 7 hours, remove the virus and add in feeder cells so that then the cells can grow happily. Which means 3 hours before the 7 hours, I have to mitomycin the feeder cells. I need to prepare the feeder cells. So I will do that in a few hours. Now all that's left is what to do with the rest of the cells. I think what I will do... Do I have any feeders? Okay. I'm going to plate some onto these feeders just in case I want to use this skin cells for anything else. But other than that, I'll just freeze the rest down. So just put this in. I'll turn this off. These are plated, I'll put them in the incubator. And then to freeze the rest down, I need to spin these, but I'm using the centrifuge, so I'm going to go next door quickly and use their centrifuge instead. So I'll be back in a sec. Hopefully the microphone will stay connected this whole time, and then I can talk to you. Although, I hope you've been enjoying the lab work and a new angle of the lab work. I think it could be quite fun. I'm thinking of titling the video something like POV something. I haven't figured out what yet. But yeah, I hope you're having a lovely weekend if you're watching this at the weekend. Otherwise, I hope you're having a lovely day. Maybe you're already asleep, or you're studying / working. Okay, so those are spinning. I'm going to come back and label some files. Hello. Okay, so we worked out earlier. Just writing stuff down in my lab book. So I had 3.5 million cells in total, and then I've taken 1,380 microliters, so 1.38 mils, which is 760 times 1.38. So I've used just under 1 million cells, so I've got 2.5 million cells left. So I'm going to freeze 5 vials. Each with around 500,000 cells in. Prior vials, and I'm going to label them. This pen is really satisfying to write with. Okay, there we go. Files are labelled. And let me get out the cell banker. So to freeze the cells, we basically spin them down and then resuspend them in a 50-50 mixture of cell banker and growth medium. Cell banker is a cryopreservation medium. I'm also going to take the lids off of these. And hopefully, I'm going to go back to the centrifuge. Hopefully they're almost done spinning. Oh wow, perfect timing. There was 6 seconds to go. There we go. So the cells are pelleted. So what I need to do now is aspirate the medium. And then I want the final volume in each vial to be 500 microliters, which means I need to add 5 times 250 microliters of medium and cell banker to make the 50-50 mix. So 5 times 250 is 1.25 mils. So I'm going to add 1.25 mils of medium and 1.25 mils of cell banker. And then just put that up and down. Let's give them a mix. So I should have 2.5 mils. I'm going to add 500 microliters to each vial. Back on. Let's be careful with the lids to not touch the actual bit that will go inside the vial. And there we go. So I'm going to put these on ice because the self-freezing medium is actually quite damaging. And then I'll go and take them to the -80 freezer. But that is about it. I'm done. Took 77 minutes. which was roughly what I was expecting. I feel like there's there been something fuzzy. I did try and clean this at the start. Maybe it's reflections. Anyway, hopefully you've been able to see me well enough. But yeah, I hope you enjoyed this video. Quite fun. I think I'll probably do some more, if you like it, of you guys inside the hood. I think it's quite a good angle, and probably, hopefully, for some of you, interesting to see what I'm doing, how I do tissue culture and stuff. But yeah, I hope you enjoyed the video. Do let me know what you think in the comments. Give the video a like if you liked it. It really does help the channel. Subscribe if you're new and you're not subscribed already. Other than that, yeah, have a wonderful rest of your day, and I will catch you very soon in the next video. Goodbye.